Hello everyone. Today we are going to see a new topic, that is PDA, Pushdown Automata. Okay, so here's the question. Obtain a pushdown automata to accept this language. Okay, they have given one language, that is L of M. Okay, so they have a string and a C constant and again a string. So W is nothing but the string, any string. It can be like ABB or ABB, BBA. Okay, and it's a string reverse such that this W belongs to A plus B. Okay, means the whatever the string we are going to do, that belong to A or B whole star. So A or B whole star means it can be any number of A and any number of B. Okay, and they're saying W to the power of R is a reverse of the W. So whatever the string we take in the W, so in the middle we have a C constant and we have a W to the power of R. Okay, for example, if you take AB double A, so we'll have a C constant, so we'll have a reverse of this one, that is double A BA. Okay, so now we are going to do this one into a push-down automata question. So how we are going to do means, so we are going to use a stack logic. Okay, so we are going to use for a stack logic for this push-down automata. So what we are going to do, so we are going to push all the inputs, the first part of the input, into the stack. For example, in the given example, you have A, B, double A. So we'll push the A, it'll go to the top of the stack. Then again we'll push the second B, that goes to the top of that. Again the third A, again the fourth A. Okay, so whenever we see the first part of the input, we are going to push into the stack. Then whenever we see the C constant, after seeing the middle variable or a C constant, we are going to pop the element. So how we are going to pop? So it is whenever we pop the stack, it is always from the top. So we have A and we have a input. Again we'll go, now this is the top of the stack. So again A is matching. Then we'll again continue. We had a B, we had a matching B. Again we'll continue. We had a and we have a matching A. So whenever we have a same element that is reverse in the second part, then only our stack logic will work. Okay, so this is the basic idea of the pushdown automata. Okay, now we'll see quickly how to write a pushdown automata transitions for this given question. Okay, so in the transition, till now the DFAs have only two transitions. One is state and one is input. From now onwards, we'll have a different transition. So that will have a three parts. So what are the three parts means? First one is the state, second one is the input, and the third one is the top of the stack. Okay, and the same way in the output also, we'll have the output state and what is the top of the stack. Okay, so to make sure our stack is empty, so we always start pushing a Z naught. Okay, we'll always push the Z naught to the top of the stack, so that whenever it is pointing to the Z naught, we'll come to know that the stack is empty. Okay, so first step we'll start like this. So we'll have a two set of inputs. Okay, that is A input and B input. Means we'll write a transition, that is Q naught on A and Q naught on B, such that the top of the stack is empty. Okay, so I'll tell it once again, the input logic. So we have a transition, we have a Q naught, we have a as an input, and we have a Z naught, that is the top of the stack. So whenever we have this logic, it goes to the Q naught state itself, the same state. Now the stack was Z naught, the top of that A was pushed. So now the stack is A and Z naught. So it means something like this. So right here, so we have a top of the stack, we have a A like this. Okay, so same way whenever we have the B input, the stack is empty, just we'll push that element to the stack. So that is Q naught, B and Z naught. Okay, so this is the first two transitions. Okay, whenever the stack is empty, we can have a two set of inputs, that is A and B. Whenever we push the A, it becomes A Z naught. Whenever we push the B, it will become B Z naught. Okay, so this is the first combination, or you can say it's the first group of transition. Now the second group of transition, whenever the top of the stack is A and the top of the stack is B. So initially we took two combination, that is empty stack. Whenever we have A and B, we'll have a four logics. Okay, four type of transitions. We'll write that one. So first one is whenever we write a transition, so we say it's a Q naught, our input is A and our top of the stack is already A. Then what we'll do? We'll do like this: Q naught, already A was on the top of the stack. We are pushing our new A to the top of the stack. So it becomes A and A. So same way, the second combination, the top of the stack is A, but our new input is B. Then we'll push that also into the stack. That is Q naught. So already A was in the top of the stack. We are setting the B on the top of the stack. Okay, so now we have two combination. Again we'll see the next combination, that is Q naught on A and our top of the stack is B. Same logic, we'll write one more transition also. Q naught on B, already our top of the stack is B. Okay, so then also we'll be in the same Q naught state and we are going to push the new input. Okay, already B was the top of the stack, we are pushing our new input A, so it becomes AB. Okay, same way, Q naught, already B was in the top of the stack and we are pushing up new B, so it becomes BB. Okay, so this is the second set of combinations. Okay, now we'll go to the next condition. Okay, so now we were always around Q naught. Why? Because we are not changing any state, because in this all the states we are just pushing our input, that is this part of inputs. Whenever we see this part of the inputs, just we are pushing it to the stack. Okay, once this is done, now we want to check for this symbol, that is the C constant. Okay, that is the next group. Okay, we'll see the fourth combination. So that is transition Q naught on C. That is, in C is the new input and the top of the stack is empty. We want to check this condition also. So then what happened? We'll keep it empty as it is. We don't do anything. We'll directly go to the Q1 state and we keep the Z naught as it is. Okay, means if the first part of the input is empty, okay, that is also possible. So we will go to the next state, Q1 state, and keep the Z naught empty stack as it is. Okay, again we are going to go Q naught on C if our input is A. So what we are going to do, we are going to convert the Q naught state to Q1 state and we keep the A on the top of the stack as it is. Okay, and then we have a Q naught. Again we read the C as an input. Now the top of the stack is B, our input is C. Now also we are not going to change anything into the stack, only our state will change from Q naught to Q1. So we'll keep the top of the stack B as it is. Okay, so this is for the C input. Okay, again after all this one, okay, now we are went into the popping state. Till now whatever we saw was pushing state. Now we want to go for the pop state. Okay, I'll write this transition in this part. Okay, so how we are going to write? So that is transition. So this is fifth part. Okay, so that is Q1 on A and the top of the stack was A. So then what we want to do, we want to be in the Q1 state itself, but we want to pop the element in the top of the stack. So that one we denote with the epsilon. Whenever you see the A input, the top of the stack is also A. Whenever we see the A input and the top of the stack was A, then only we are removing it, popping it. So same logic. And again second transition, we are in Q1 and our input is B and the top of the stack is also B, then matching, then only we'll change the Q naught to Q1 and we'll go with the epsilon. Okay, so here we don't have other two combination. Why? Because whenever we are popping it, we should be very conscious that we are only popping whenever we have a matching element. Okay, so that's why we don't take other two combinations. Okay, that is not allowed. Okay, so these are the transitions, and after all this one, the final state. Okay, after repeating this Q1 state continuously for all these inputs, we want to confirm our final state. So what is our final state? That is Q1 on epsilon. On epsilon means there is no more input to be allowed, and our the top of the stack is Z naught. The stack is empty. Then we say directly go to the Q2 state, that is Z naught. Keep the stack as it is. So Q2 is the final state. Okay, Okay, so for today's session, we'll stop in the transitions. In the next part, we'll learn how to convert this transition uh, into a state diagram. Thank you for watching. Subscribe and like for more such videos.